Aloha, Algebra 2. All right, here we go. Chapter 8, Rational Functions. Remember, you can go to my website if you want the guided notes. Okay, you click on Chapter 8, which takes you to our videos, right? There's our Chapter 8 videos. And then if you go to Notes, or we go to Notes, we're starting out today in Section 8.2. All right, it's the reciprocal function family. So once again, and one thing that we've gotten very good at in Algebra 2 is graphing, all right? Remember little RST? And so what we're going to do is we're going to extend that now to what we call the reciprocal function family. All right, here's kind of what the graph looks like of a reciprocal function family. And it has two very important characteristics of a reciprocal function. And it is that there will be what we call a vertical asymptote, which means the graph is not allowed to cross it vertically, and a horizontal asymptote, which means the graph is not allowed to cross it horizontally. If you look at the graph right now that's in my picture, you guys, this graph, believe it or not, is never going to cross this y-axis, which we say is at x equals 0. That's called a vertical asymptote. Why? Because it's vertical. And then we have what we call a horizontal asymptote at what we call y equals 0, and it's never going to cross that. So the important characteristic of reciprocal functions is that they're not going to cross vertically somewhere and horizontally somewhere. And we're going to have to make sure we really pay attention to those, okay? All right, so here we go. Now, in your guided notes, just here's some very important information, but don't worry about it, you guys. With some of the examples we're doing, we're going to be talking about it. All right, I got my blank screen right here. All right, this is where you want to take some really good notes. But the more problems we do, the more notes you guys need to take. All right, now here we go. A reciprocal function, parent function. Okay, it looks like this. Y equals 1 over x. That's as basic as you can get. And then we do a little RST to that bad boy, but let's start just with the basics, all right? Remember, whenever we graphed anything in Algebra 2, we always did an X and a Y table, okay? And now if you notice, there's one number I'm not allowed to have in that guy, right? And when we did most of these graphs, we would normally put a 0 in. But if I put a 0 in this guy, I get 1 over 0. And you can't do that. You can't do that. And believe it or not, that means there will be a vertical asymptote at x equals 0. But instead, what I'm going to do is I only have to pick two numbers, believe it or not, a -1 and a 1. If I plug a -1 in there, I get 1 over -1, which is -1. And if I plug a 1 in there, I get 1 over 1, which is 1. So those are, believe it or not, the only two things I got to graph. Well, the only 2 points I got to graph. So we got 1 comma -1, which is right there. And we have 1 comma 1, which is right there. And then I just have to pay such good attention to where I have asymptotes, okay? And I'm going to even use a different color. Now remember, I said earlier you can't put a 0 in there because at x equals 0, you get DNE. So I've got to draw a vertical asymptote all the way down x equals 0, and it can't cross it. Can't cross it. No way, Jose. All right, but then this guy also has what we call a horizontal asymptote, and it is at y equals 0. Okay, and that's like if I plug something really, really big into the bottom here, like infinity, this is going to go to 0. And that is why we have a horizontal asymptote at y equals 0. Now, believe it or not, I can draw a graph. Why? Because a graph goes to the asymptotes. So it's going to get closer and closer to that bad boy, but it's never going to cross it. It's going to get closer and closer to that bad boy and never going to cross it. And I do the same thing down here. And I just got to make it look like it's going towards that asymptote, but it's never going to cross it. And that's it. That is it. Sweet. Now, can it get a little bit tougher? You better believe it can get a little bit tougher. So let's go ahead and look at a problem that maybe gets a little bit tougher. All right, so that was the parent function. So the real true problem we got here is example Ichiban or 1. All right, here we go. Y equals 1 over x plus 3 plus 4. Oh, snap. Now remember, this means we're going to introduce R, S, and T. Remember, R stands for reflection, S stands for stretch or shrink, and T stands for translation. Remember my side work now. I'm going to always start with my parent function, and I'm going to write down how that parent function changes. Remember, and I got to only know 2 points. -1, 1, 1. And this is for a reciprocal function, okay? All right. Is there a reflection? Well, is there a negative in there? Is there a negative here out in front of this function? There's no negative. So we say no vertical. And make sure you write this out really well, right? You guys take good notes. No vertical reflection over the x-axis, okay? All right. Is there a stretch or shrink? Now, in reciprocal functions, usually we would write something if there was a number in front, but this time we write a number if it's on top. So if there was like a 2 on top, that would be like 2 times 1. So there would be a vertical stretch by 2. But since there's still just a 1 on top, we didn't multiply it by anything. So we say no stretch or shrink. Remember, a stretch is if that number, in this case, if the number above was bigger than 1, okay, then it would be a vertical stretch. But in this case, there's no, I should say, no vertical stretch, okay, or shrink. Remember, shrink happens if my number's between 0 and 1. So if that 1 was maybe a 1/2 up there or something like that, KKs? And then translation. Now, hopefully we remember from earlier that that +3 means there's a translation, and that actually means there's a translation of 3 units. You guys remember? Do you guys remember? Say it, say it, say it. Left. Remember, it's kind of like we do the opposite. And then that number that's outside of the function affects it vertically, remember? So we would say that's 4 units, and we do exactly what that bad boy says. So we would say 3 units. Okay, and so here we go. Now what do I have to do? Okay. Remember, there's some important stuff going on here. And remember, if we go back to when we graphed earlier, we kind of did table of values for R, S, and T. Now for R, there was nothing that changed. So it's still -1, 1, 1, and 1. Now there was no stretch or shrink. So we're still at -1, -1, 1, 1. But there was translations. So things will change. Let's see how they change. Well, remember, we go to the step before, and it says move 3 units to the left. So that means I'm going to move this 3 to the left and 3 to the left, which -1 minus 3 would be -4. 1 minus 3 would be -2. And then we go up 4, which means I'm going to move these up 4, which means -1 plus 4 is 3. 1 plus 4 is 5. So I've got new points. 1, 2, 3, 4. 1, 2, 3. Booyah. And then what else do we have? I've got -2, 5. So there we go. There's my 2 new points. Now, if you remember, we had these very, very important vertical and horizontal asymptotes. Remember, the first vertical asymptote happened at x equals 0, but now I shifted it 3 to the left. So guess what? If for this guy over here, I had a vertical of VA, I had a VA at x equals 0. For this guy, I had an HA at y equals 0. Believe it or not, to find out where they are now, all you have to do is translate them. Let's move it 3 units to the left for the x. That means I'm going to have a brand new guy. It's going to go stacked. I should have made it red. Gosh darn it. That's okay. X equals -3, right? And then that would be my vertical asymptote. And then y equals 0 was the horizontal, but I'm going to move it up 4. So now it's at y equals 4. And that's the horizontal. And remember, it can't cross those bad boys. So those are the only 2 new points I need. And I go spling, 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 and it's done. Remember, it goes towards the asymptote. It's not going to cross them, but it's going to go towards them, okay? And that's our graph of a reciprocal function. That's it. I want to do 2 more with you guys. And then we have a couple of word problems that we're going to finish the day with, okay? All right. Let's go ahead and look. I'm going to do 2 more with you guys. We're just going to build upon it. All right. And then you want to make sure you do your math Excel. All right, class. Example 2. Example 2, y equals. I'm going to introduce a 3 up there. Okay, x minus 2. And then let's go plus 5. All right. So here we go. Remember, we always start with a little bit of side work, which would be our parent function. And there's things we want to remember about our parent function, which is -1, -1, 1, 1. And then remember, we have what we call a vertical asymptote at x equals 0, and we have a horizontal asymptote at y equals 0. Remember, those guys are really super duper important. All right, we go a little reflection, stretch, shrink, and a translation. No reflection. Why? No negative out in front. So we're going to say no vertical reflection over the x-axis. Do me a favor. Make sure you write out the word vertical and reflection, okay? Just trying to save you some time here with your notes. Stretch, shrink. Oh, yeah. There's a 3 up top. If there's a 3 up top, that means I multiplied this 1 by a tree. 1 times, that means there's a vertical stretch. Because if I multiply something by 3, remember, it stretches it. So vertical stretch by 3. And then translation. Remember, x minus 2 would mean 2 units. Say it, say it, say it. To the right. Good job at home. Yes, yes. And then we got 5 plus 5. That's outside, so it affects it vertically, which means up and down. Plus 5 would be up. So 5 units up. Okay, and then what do? Well, we do our little table of values, right? We got a little R, a little S, and a little T. Then I can graph it, right? Swing, 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 swing. All right, remember, we start with this guy over here. There was no vertical reflection, so I stay the same. All right, and then we stretch it by 3. Remember, vertical means it only changes the y's. So that means my x's are going to stay the same, but I'm going to stretch my y's by a 3 times -1 and a 3 times a1. Are we good, goods? And then how do we finish this bad boy up? We finish it up by translating it 2 units to the right. So I go to the step before. 2 units to the right would mean you change the x's, which it becomes 1 and 3. Why? Because -1 plus 2 is 1. 1 plus 2 is 3. And then I go to the step before, and I'm going to change the y's plus 5. -3 plus 5 is 2. 3 plus 5 is 8. So guess what? To get this graph, I only have to graph those 2 points. 1 comma 2 and 3 comma 1 2 3 4 5 6 7 8. Boom and boom. And then remember, the most important thing here is, what am I not allowed to cross? And you're never allowed to cross asymptotes. Well, where are my asymptotes? Remember, it was at x equals 0, but I shifted it 2 units to the right. So I'm going to make my new asymptote at x equals 2. And I got to label it. X equals 2. Not allowed to cross it. Not allowed. And then we go up 5. So I'm going to move that guy up 5. 1, 2, 3, 4, 5. And I'm going to draw a dashed line through that. Why is it a dashed line? Because it's not really part of the graph, but you're not allowed to cross it. And then guess what? Let's go to the asymptotes, and make it like nice and curved. I'm doing a decent job. Oh yeah, donezo. That's it, you guys. That is the graph of a reciprocal function. We got one more of these to do. If you notice, there's one piece that I skipped out on. In class, anytime you're like, Mr. T, you going fast, dude, then just hit the pause button. Okay, pause it up for a moment. All right, you guys. All right, here we go. Example 3, my last one. All right, the last one of the day. We go of the graphing. Sorry, y equals -2 over x plus 3. And then this time, let's go -4. Ooh, we got a lot of negatives going on here, so let's be careful. Remember, we always start with our side work or our parent function, which is 1 over x. Let's do that table of values. Remember, we always start -1, -1, 1, 1. Remember, we got a very important vertical asymptote at x equals 0. We have a very important horizontal asymptote at y equals 0. Okay, guys, let's go. All right, you get points, remember, to telling me if there's a reflection, a stretch or shrink, or a translation. Is there a reflection? Is there a negative out in front? Yeah, kind of. Right? We got that negative up on top. That's kind of like out in front. So this time we will say there is a vertical reflection, okay, over the x-axis. Boy, that's going to change some stuff. It means we flip it. Okay, we flip it, okay? Is there a stretch or shrink? And guess what, class? There is definitely, oh, I got a fire alarm. Sorry, guys, we had a little bit of a fire alarm. All right, so here we go. Let's keep going. Is there a stretch or shrink? There definitely is a stretch or shrink because you see that 2 up there, right? And there normally was a 1 in the parent function. So if I multiply it by 2, it's going to give me a vertical stretch. We're going to say there's a vertical stretch by 2. Okay, and then last, remember, we have our translations. That would mean 3 units. Say it. 3 units to the left. And last but not least, that's a minus 4. So that would be 4 units, remember, down. All right, so remember, we only have to work with 3 points. 3 points. Come on, Mr. T. 2 points. And there is a reflection this time. So remember, we start with this over here. And if there is a vertical reflection, remember, vertical means you only change the y's, which means I'm going to change the y's and I'm going to change their signs. If I multiply that by a -1, it becomes a positive 1. If I multiply that by a -1, it becomes a -1. Stretch, shrink. There is a stretch. There was a stretch by 2. Remember, it always comes from the step before. So since there's a stretch by 2, I'm going to multiply the y by 2. I'm going to multiply the y by 2. So you notice I'm only changing the y's here. Why? Because it's vertical, vertical. The first time you affect something horizontally is when you get to your translation. And we're going to take my x's and we're going to go 3 left, which means -3. So -1 minus 3 is -4. 1 minus 3 is -2. And then 4 units down, 2 minus 4 is -2. -2 minus 4 is -6. So those are my brand new points. Those are the 2 points I'm going to graph. 1, 2, 3, 4, 1, 2. And then 1, 2, 1, 2, 3, 4, 5, 6. There are my 2 points. Now, what the heck is this going to graph look like? Well, guess what? If I draw my asymptotes, I'll be good to go. Remember, my parent function has one at x equals 0, and I'm going to have to move that x 3 to the left. So my new vertical asymptote happens at x equals -3. And then I got to go 4 units down, 1, 2, 3, 4. And it's going to change that to be y equals 4. So it can't cross those guys. So what would this look like? And we have to remember that this graph was reflected over the x-axis. So that part usually was on the other side and vice versa. But as long as we remember that it always goes to the asymptote, you're good to go. All right. That is it with graphing today. Do your math Excel, practice these graphs at home. A good way to practice is to rewrite the problems we just did, see if you can do them again from scratch. And if you can, your money's for our quiz test coming up here very, very shortly. All right, you guys? All right, 2-word problems. Okay, hopefully you printed this out because it's nice to have it available. Okay, but we got Chad. Chad can paint a room in 2 hours. Cassie can paint the room in 3 hours. If they use some teamwork, how long would it take them painting the room together? All right, so we always want to introduce a variable, okay? And we introduce the variable with something we know nothing about. I don't know about you guys, but I don't know anything about in terms of how long it takes them together. So let's let x equal time working together, right? And that's the time it would work them together to paint the room, to paint the room. Okay, we just got 1-word problem. We're going to call it a day. All right? All right. So let x equal the time working together to paint the room. So let's check this out. The way you set these problems up are kind of like reciprocal functions. All right, we got Chad. Chad. Chad can do one job in 2 hours. Okay? One job in 2 hours. Cassie can do the one job if she's by herself in 3 hours. All right. And the question is, if they work together, how long will it take them to do the one job in X hours? Okay, guys? And then, whew, I don't know about you, but I don't like fractions. So whenever we don't like fractions, remember, we get rid of fractions. Well, how do you get rid of fractions? Well, you find an LCD, lowest common denominator. The best way to find a lowest common denominator, or just let's say, actually, you just really need a common denominator. You multiply all the denominators. So what's 2 times 3 times x? Well, 2 times 3 times x is 6x. So we are going to do what we call clear out all of the fractions. And the way we clear out all of the fractions is we are going to multiply everything by 6x. So first, I'm going to make it look a little better. So we got 1/2 plus 1/3 equals 1 over x. Now I'm going to multiply everything by 6x. Okay? So how do I multiply everything by 6x? Well, the way I would do is I would show it like this. Okay? And then we would do 6x times 1/2, which might be side work for some of us. 6x times 1/2. Well, that would be 6x over 2, which would be 3x. So that's my first answer. This times this, that'd be 3x. Okay? Erase my side work. Spling, spling. And then I got some more side work. Sorry, I got to erase you guys. I'm just running out of space. And then we just have to multiply 6x by everything, 1/3. Well, that would be 6x divided by 3, which would be 2x. And that would be plus 2x. Okay, that guy's done. And I got one more to go. And I got 6x times 1 over x, which would be 6x over x, spling, spling, which is equal to 6. And then just what? Guess what? Just do math. 3x plus 2x is 5x equals 6. Divide by 5, divide by 5. X equals 1 1/5 hours. So hopefully that totally makes sense. If Chad can do it in 2 hours, right? Chad can do it in 2. Cassie can do it in 3. If they work together, they're going to work faster unless they just start chilling. All right, that is it. Go do your math Excel. Bring your questions tomorrow in class, and we will work on more of these guys, right? And I know there's one more problem, but it's a little bit tougher. We'll do it together. Aloha.